You tap a screen, type in a website, and hit enter. Almost instantly, a video or an article appears. It feels like magic, as if all this information lives in an invisible cloud floating in the air, ready to be pulled down whenever we want it. In reality, every bit of data moves through a massive, heavy physical machine. When you hit enter on your phone, your request travels invisibly through the air for only a few hundred feet before hitting a physical cell tower. From there, it is wired directly into a vast network of copper cables and huge warehouse-sized data centers. To cross an ocean, your data travels as pulses of light through glass fiber optic cables. These are laid directly along the seafloor by huge, specialized industrial ships. Every time you load a web page, photons are literally traveling through glass fibers across continents. The internet is a multi-trillion-dollar industrial project that physically wraps around the entire globe. Decades ago, this kind of global connection was impossible. Computers were massive, room-sized machines built for specific military or university projects, and they were completely isolated. A computer built by one company couldn't talk to a machine built by another. There was no central boss to force everyone to build things the same way, so these separate networks lacked a shared language. Researchers eventually developed shared rules for communication. Think of it like deciding that no matter where we are from, we will both agree to speak the same language during a meeting. If two different computers follow these same rules, they can suddenly exchange information. These shared rules transformed isolated tech islands into a single, leaderless network. No one owned it, but everyone could participate. That foundation set the stage for every request we make today. Now, let's trace the actual physical journey. We can follow exactly what happens in the fraction of a second after you hit enter on your browser. First, your browser has to find out where to go. Computers don't understand names like Google.com. They only understand numbers. Your device checks a digital phone book, translating the name into a unique numerical address. It gives the network a precise location, so your data can be stamped onto an envelope and sent to the exact computer holding the website. Before the request leaves, your computer performs a security handshake. It scrambles your request and locks it up, much like putting your mail inside an armored car. This ensures that only you and the destination can read what's inside. Once the address is found and the armored car is locked, the physical journey across the globe begins. When the destination computer receives your request, it prepares to send the data back, but it doesn't send the web page or video as one big single file. Instead, data is broken down into hundreds of thousands of tiny, independent chunks. It's like shattering a giant Lego castle into individual bricks before mailing. Each brick is placed in its own envelope stamped with your digital address. Then they are all dumped into the global system to find their way back to you. As packets travel along physical cables, they hit intersections. Specialized traffic cops sit at each one, using routing rules to ask, what is the best next step? If there is a traffic jam or a broken cable, it forces the data down an alternate road. A single video might arrive in 100,000 pieces, with each piece taking a slightly different path across the world. This independent routing is the system's greatest strength. It allows the network to easily survive broken cables or heavy traffic. Because the pieces took different physical routes, they arrive at your phone in a chaotic jumble, completely out of order. Here, a delivery protocol steps in, acting like a strict supervisor checking the manifest as pieces arrive. If one is missing, it requests a new one immediately. Once accounted for, it snaps everything into perfect original order. Your browser instantly paints this reassembled code into the website you see. This entire intercontinental journey, from your tap to the final image, took less than 200 milliseconds. The system functions without a central brain or a boss. It works because millions of separate machines simply agree to follow the same rules, cooperating to move information across the globe in the blink of an eye.